Hello students, this is Shivakrishna from Civil Department in Anurag Engineering College. I would like to explain about the subject of Structural Engineering 1. In the Structural Engineering 1, design of beams, columns, slabs and staircases, columns totally involved in the particular design. What is meaning of design? Design is nothing but find out the cross section of one element. It is called design. For ultimate loads, we have to design for the ultimate loads for applying some factor of safety in that beams and how much load acting on that beam or structural elements or any particular column or slab, beam, footings, that should be totally calculated. And for that loading condition, how much movement should be acting on that pavement, and acting on that movement, how much area of steel it should be bearing on that particular movement. It should total this all parameters I have to study it in this subject. So in here I would like to introduce the one of the concept of beams. Beams is the very important element in the structural engineering. Okay, in the structural engineering, beam is a combination of concrete and steel, and these concrete beams are structural elements. These are designed to carry transverse loads. These loads causes bending moment, shear forces and thrust moments. Some of the cases it should be thrust moments also we have to consider in that design. Next, concrete is strong in compression and steel is strong in tension. So, but in this section, the concrete will not responsible for tension. So that's why we are considering here for fulfill the amount of tension forces we are introducing the reinforcement. This reinforcement should be capable to responsible to tensile forces. Beams it should be categorized into different types that are simply supported, cantilever, continuous, fixed beams and continuous proper cantilever. These types of so many types of beams are available in the market. In these types of beams, it should be coming into structural engineering. The beam should be categorized into three types. What are that means? It is mainly focused in singly reinforced beams and doubly reinforced beams and flanged beams. First, coming to singly reinforced beams. What is the meaning of singly reinforced beams? In a particular beam section, the tension reinforcement should be provided in the bottom side of the beam is called singly reinforced beams. Here the reinforcement should be provided in the one direction only, that is bottom side of the beam only if you have to prefer in the area of reinforcement. And next one, doubly reinforcement. Doubly reinforcement means it is say it as doubly means either compression side or either tension side the reinforcement should be provided. It is called doubly reinforcement. Why it is called doubly means both compression phase and tension force, like area of steel provided in the compression phase and area of steel provided in the tension phase. In singly supported, the area of reinforcement should be provided only tension side of the beam only. That is the difference between the singly reinforced and doubly reinforced beams. Some of the cases, at a time monolithic structures should have to construct in particular locations. This type of locations, some of the monolithic elements should be introduced in the structure. That monolithic structure, it is called T-flanged beams. That flanged beams is called T-beams or L-beams. T-beams, in this scenario, the beam and slab at a time it should be constructed in that particular location. That is called flanged beams. So these are the mainly depending upon the type and depending upon the reinforcement position and depending upon the movement condition and depending upon the loading condition, means some of the additional loads will be acting on that particular beam. We have to prefer doubly reinforced. Extra loads means some of the examples, headrooms we have to consider in the design. That headrooms also, it is additional movement. That additional movement we have to prefer doubly reinforced. But compared to simply supported and doubly reinforced beams are uneconomical structure compared to singly reinforced structures. Next, coming to material behavior of the concrete and steel. In this stress strain curve for concrete, the concrete it will be made in the laboratory. We are manually mixing on that concrete and we are manually taking the specifications and we are manually applying the load. Okay, these all are parameters we have to consider in the designing the design strength, finding the design strength of the concrete specimen. In that concrete specimen up to 0.002, the strained should be non-linear portion, it will be applied. After that, up to 0.0022 up to 0.0035, the strain curve should be maintaining as a linear section. Okay, in this, three curves should be acting on that pavement, acting on that location. In these three locations, first of all, design curve, characteristic curve for structure, characteristic curve for cube. Okay, here cube is the actual structure that will be made in the laboratory, and actual structure we are not compromising the loads. So in that situation we are applying some factor of safety. When dividing the with the factor of safety, it should be look like as a 0.67 FCK. FCK means it is a characteristic compressive strength of concrete. And this example it will be taken as into design. Design means we have to applying the some factor of safety due to ultimate loads. For that ultimate loads we have to again applying the factor of safety. This factor of safety it will be divided with that, it will be getting that 0.45 FCK. In that situation, the characteristic compressive strength maximum stress strain curve up to beyond what is the maximum extreme fiber means 0.0035 only. And what is the maximum stress means FCK value, it will be taken as the 0.45 FCK for design point of view. And coming into the steel material, in this material it will be steel, it is made up of in the factories. In these factories design parameters are highly preferred. So in this case some of the proof stress may be involved here. Why? Because this total mild steel and HYST bars totally depending upon the carbon content mixing in the particular manufacturing process. This carbon content will be increases, the ductility nature will be decreases. So this position, the total here also we are considered two types of lines, that is the one is the characteristic curve and one is the design curve. Here not in the cube. Why? Because it is not manual and not prepared any manually. So in this situation the design curve by 1.15, why it is take and factor of safety 1.5 means concrete will be made up of by us and the steel will be made up of by some factory. In that factory workers we are applying the high configurations and high design parameters. So that's why only compared to concrete the steel of the factor of safety will be taken as the lesser value. Okay, and next one, cross section of the beam. This is the typical cross section of the one particular beam. Here I consider doubly reinforced beam. Here look like in the bottom section also we have to provide in the area of the reinforcement, and the top side also we have to provide the area of the reinforcement. This is the width of the section, and small d is the effective depth of the section. Effective depth means that is the distance between the extreme fiber to and half of the diameter of the area of the steel. This is the effective depth. And d dash means effective cover. Effective cover means up to the distance between the bottom fiber to center of the area of the steel. This is the B option is the strain diagram, and C option is C diagram is C is the stress diagram. Here the based upon the strain curve, stress strain curve for concrete, stress strain curve for steel, the extreme fiber it will be 0.0035 on the compression side and 0.87 Fi by Es plus 0.002 for tension side. Here the neutral axis will be divided in that beam in the two different cross sections. In this dividing by two, the neutral axis it is called, what is the neutral axis means, when the compressive forces and the tensile forces where it should be equal, that line it is called neutral axis. In this neutral axis it should be plays a very important role under defining the type of section. In this type of section, in the stress curve, and the ultimate extreme fiber is 0.446 FCK only it we have to maintain. Okay, here some of the lever arm also have to mention, that is 1 d minus 0.42 XU up to center of that axis. Based upon the neutral axis, the beam should be categorized into three types. What are that? One is the balanced section, one is the under reinforced section, and one is the over reinforced section. These total three sections will be depending upon the depth of neutral axis only. When the neutral axis will be equal in compression side and tension side, that should be balanced section. Here balanced section, the steel and concrete reaches the maximum permissible values at a time equally, but in the under reinforced section, the steel should be reached maximum value, and the concrete should be not reaching the maximum value. But here in the over reinforced section, the concrete should be reaching in the up to reaches the maximum permissible limits. So this is called balanced section, under reinforced section, and over reinforced section. Next, coming into the design procedure of singly reinforced beam. Okay, one particular singly reinforced beam, some of the several factors you should be designed on that particular location. First of all, first means data collection. What type of data if you have to need for design of the singly reinforced beam means what? Data type of section, rectangular section, and type of beam, is it simply supported or cantilever or continuous beam, and what is the grade of steel used in this particular design, and what is the grade of concrete it should be used in that particular design, and what is the next, what is the load acting on that beam, what are that movements due to that loads. These all parameters we have to necessary to finding the design. And data collection, based upon the span we have to consider up to 10 meter span, we have to prefer this span to effective depth ratio values. Simply supported beam we have to consider 20, cantilever beams we have to consider 7, and continuous beam we have to consider 26. Some of the cases more than 10 meter span beams also available in that particular location. In that situation we have to prefer for simply supported 20 into 10 by span, and cantilever no need to consider here any particular value. Why? Because here more spans cantilever beams are not preferred in that particular location, and continuous span 10 way span into 26 times you have to consider. And after doing that span consideration, we have to find out the load calculations. Based upon the loading calculations, the load should be categorized into different types. That load should be taken as the dead loads, live loads, wind loads, snow loads, and earthquake loads. These total loads should be, and self weight also we have to consider, and any finishing loads we have to implement it, that is also we have to consider. In this total the load calculation, we have to find out shear force and bending moment. What is the occurrence of shear force and bending moment here we have to consider. we know all the formulas for how much load acting on that pavement due to point load, due to UDL, due to varying load. In that case, what is the shear force on that particular beam, and what is the bending moment on that particular beam, and what is the bending moment for simply supported, bending moment for cantilever. This type of reactions and the type of loading conditions, we have to consider different shear forces and bending moment. And the next one, after finding the moments, for that bearing of that moment, we have to consider area of reinforcement. Area of reinforcement, simply I give it as a simple formula, that is 0.87 Fi ASTD 1 minus AST Fi by BD into FCK. We already know from the moment, due to that moment, how much AST it should be provided on that particular location, it should be taking for the tension reinforcement. Here tension reinforcement only provide in the bottom side of the beam only, that is single reinforcement. So AST enough. And after that, shear reinforcement means AST means that is the top and bottom side of the main bars, but in the middle of the bars, that is the shear reinforcement. What is the use means, this is the precaution of over sliding on that stirrups, or not merging with that top and bottom fiber of the reinforcement. So shear, we have to find out the we have to predict the shear failures, we have to provide shear reinforcement. In that shear reinforcement depth, what is the spacing of that intermediate shear reinforcement means ASV by BSV greater than or equal to 0.45 by 0.87 Fy. Here AST, area of shear reinforcement, B is the width of the beam, and SV is the spacing of the reinforcement, Fy is the characteristic compressive strength of reinforcement. Here check for deflection also. Due to loading acting on that load, the deflection will be considered. That deflection also, this is depending upon the loading condition and type of the beam. The load should be different types, like simply supported with UDL, cantilever with UDL, cantilever with point load. This depending upon the loading conditions, the deflection formulas will be choose and find out the remaining allowable deflections. This both satisfactory in condition, it should be capable to use. Next, coming to design procedure of doubly reinforced. What is the difference between same procedure? It will be look like as singly and doubly, but in this doubly reinforcement, only one parameter will be extra parameter we have to consider. That parameter means area of the reinforcement in the compression phase. That is the difference only between the single reinforcement and the double reinforcement. In this double reinforcement, the area of reinforcement should be provided in the compression phase also. In here, sixth step, compression reinforcement, that is the extra step to providing the difference between the single reinforcement and double reinforcement, and remaining all of the process, it should be same design procedure how to follow in the single reinforced beams and doubly reinforced beams. In that single reinforcement, we have to introduce two more anchor bars. Why? Because one stirrup, it should be capable to putting on that section. We have to compression phase hanger bars, it should be provided. That hanger bars, it should be used to 0.1% of cross sectional area have to consider in the area of hanger reinforcement. Okay, this is the mainly difference focus on the single design of single reinforced beam and doubly reinforced beam. Thank you students.